put what you do into a nutshell, um, how would you say it? I said you look into the contamination of water, whether drinking in natural waterways. Like, what would you say your kind of mission is? I understand you're a professor and you do research, but like, how would you kind of sum up what you do? I was struggling.
So I'm mostly interested in identifying public health and worker safety issues that are happening right now,
Okay.
ways that we can mitigate them, whether that means chemicals are finding their way into the environment and it's causing fish kills or some type of harm,
Mhm.
materials that we're using that leach chemicals or release things that cause harm or fail, or whether it be workers that are using chemicals or manufacturing things and their safety is at risk. So I am most interested in focusing on right where people, the infrastructure, and the environment all collide.
So you know what? Um, I'm just going to start here, Andrew. So Andrew, welcome to the Mass Construction Show. I was trying to get um, a good synopsis of what you do because you're in an interesting niche where you're doing more than just research and education at Purdue, but you really kind of have this focus on, as you were just describing, worker safety, public health. But so how did you, could you tell folks that are here, how did you get into that how did you get into that little niche where you started investigating health and safety?
I went to university, got some degrees in engineering, and then found myself caring about why are we doing things that we're doing. Worked for the Army, wanted to help people who are right in the middle of things understand like the water infrastructure and the environmental risks so that they could avoid them. And so I've really always been interested in my life with this, how do people interact with the world around them? And if we find a problem, how do we intervene and prevent it from continuing to harm them or causing harm in the future?
Hmm. Okay. And was there anything that you ever came across that's, where you saw something per se? I know you talked about kind of your experience just going through it as a worker and kind of seeing it, but did you ever bump up against something and say, "Oh wow, like look at the contamination that's happening here," or "Look at what this is doing"? Was there any one thing that kind of really said we need to dig deeper, or was it not really like a touchstone that set you off?
Well, so after working for Army, I started working for Army after September 11th because it was infrastructure security was an issue, terrorism, contamination of water systems, decon.
I get you.
And not many people really knew about that. So I spent a lot of time, working on it. And then when I went and started a faculty position, there was an incident in West Virginia. I guess my aha moment was we drove into West Virginia from Alabama, 14 hours, to help people test and decon their plumbing. And it turns out that a lot of the information that they were being given by the state, the federal agencies, and the county health department, and even the utility was like not true.
Mhm.
And I knew that because I'd worked with many of these people who were giving information publicly about how safe the water was and everything you need to worry about. So that was really kind of my aha moment. And I realized that, some people need to be helped and they don't know they need to be helped.
Mhm.
People are saying things publicly and maybe the public's consuming it and they really need to realize that somebody needs to challenge those people to make
Mm.
sure that they're standing on a foundation, not just spouting off, nonsense.
Yeah. Did you get a sense whether they were, you know, intentionally withholding things, or was it just kind of they didn't know what they didn't really understand what they were looking at, misled? Did you?
So I know for a fact, because I spoke with the governor, because they called me in,
Mhm.
that they were just repeating verbatim things that were given by the EPA, federal EPA, in
Mhm.
the DC, from Atlanta.
Mhm.
In DC and the EPA were telling the state of West Virginia things that just weren't true. And I know that because I
Mhm.
saw some of the communications. And so the state was really left with not really understanding what to do. Like, if we can't trust the EPA and the CDC to help us, who can we trust?
Great question.
So that's how I got involved. And I said,
Yeah.
look, you me, you do this, we'll bring a team in and we'll get you out of this. So.
It's funny. It was very good timing. Yesterday, I was looking at, of all things, an Instagram post from Mass DEP, um, and they were talking a lot about drinking water quality and safety. And they touched a lot on the things that people hear about and lead. And they're like, just because your public water supply is good doesn't mean that you don't have lead pipes, and you should check. And if you have well water, you should be testing it. And they start talking a lot about water testing, and they even talked a little bit about I forget how you pronounce it, the PFAS. So I don't know if
PFAS and PFAS.
PFAS. Yep, they're talking about that and endocrine disrupting hormones. And I was like, okay, like, so I kind of, the people that follow me on Instagram know that I'm always kind of railing on plastics and what they're leaching into our water supply, and pesticides and all the things that are contaminating our water. And it was very interesting to even see the Mass DEP even say, like, hey, make sure you're checking your water because there's a lot of crap in there, right? And I was like, wow, it's the first time I've heard a government agency actually allude to water safety when it's not just lead pipes. They're fine with lead pipes because it's not really their problem, right? So that was interesting, and I shared that, and I'm just like, okay, see everybody, I'm not crazy, right? Like, even our nice local government agency is saying, hey, keep an eye on this, and it means at a minimum we should probably be filtering our water. Would you say that's probably a good idea? Or
Well, I guess it depends on your water source, right? If you have a private well, you're out in the country and you've never had any other types of agriculture or anything around you, you're probably okay. But you definitely want to test it, especially if you're buying a new house.
Mhm.
Well, or if you live in a house and you've never had your well tested, you should have it tested. And you look for, VOCs, SVOCs, heavy metals like lead and copper, bacteria. And we're talking about, it's probably going to be like $600 that one time.
Yep.
But unlike a stream or a river that changes and flows all the time, right? Your well shouldn't change that much. So that's money well spent.
Yeah.
Um,
Is there a
you
good, I know you guys have the Center for Plumbing Safety, but is that a good resource for someone to go? I know I'm veering off topic here, but I think it's important if somebody, is in the situation that, they're making sure they're safe. Is that a good resource, or is there another good resource to find out what you should be testing for?
So when people call us and ask what to test for, if they're buying a new home, they're trying to sell their home, they're putting a new well in, or they may have a funny taste and odor in the water and they're on a public water supply. We generally recommend that they contact their state environmental agency, or they're actually the local public health department. Local public health departments have lists of laboratories that run tests locally for them.
Okay.
Sometimes you get a great deal on that. And so locally is generally best when you're talking about common things, lead and copper, bacteria. When you start talking PFAS and PFOS, you probably have to start talking to the state, because the state would know which laboratories specialize in that type of work. But then, the other thing is, and some of the work we do too, is disasters. So like wildfires out in California, and they had, hazardous waste, scale contamination in their pipes going homes and commercial buildings. Now you're talking about, not just a regular testing lab. You need to know what you're doing. You need to go know where to go sample, how many places in your home you have to sample. I mean, disasters are a whole different story. And that's kind of where, complexity is. We teach scientists and engineers what to do when you know what the parameters of engagement are. You don't know what's happening. Generally, engineers and scientists are not really good at that because there's no script for them to follow. And that's where we see, challenges happen.
Yeah, and that gets more into like where you become half investigator, half scientist engineer, right?
That's right. That's right. So in the best people after disaster who ask the best questions are the people who are in the homes or own the homes or the commercial buildings, because they ask you very pointed questions. Where should I take a sample? Is the water coming into my building safe? How do I know if it changes in safety, right? These are not necessarily the questions that the state or city or county people are asking. They're on a more macro level, but the true questions are the ones you asked about. Where do I get my water tested? Where should I take the sample? What should I look for? And how do I move on, right?
Yeah.
And if not, what do I treat it with?
Yeah. Or what level of contamination is safe,
That's right. That's
right?
right.
Because I'm just guessing here. I don't know this, but maybe there is probably some like obvious level of lead that's in everybody's water. I don't know. Maybe that's a lie, but I'm sure there's some chemicals that are just naturally occurring or a comfortable range. And if it's not above a certain point, then you don't have to really worry about it. But what's that range, right?
Right. So for lead, no level safe, but copper,
Mhm.
you can have less than 1.3 milligram per liter of copper in the water, and you won't have acute health impacts. Right. So there is a level of copper in the water that can be safe. And those questions are the questions that people ask.
Right.
After disasters, though, you don't necessarily know what you're looking for, which really gets people uncomfortable at the government agency level. They don't necessarily know what to test for, and so they'll just test for what they're comfortable testing for, which may not even be in the water. But that's the complexity of disasters and responding to like chemical incidents.
Hmm. Now, obviously, I'm not. This isn't my background, so pardon my ignorance here. But with a little bit of reading that I've done, I've also heard sometimes um, testing can be an issue because um, a lab will only pick up at, X parts per million or billion or something like that. But that's not necessarily
Yeah.
what's dangerous. So they're like, oh, if it's, 100 parts per million, we pick it up. Anything under that, we don't test. But at 50 parts per million, it will make you sick, right? Like, does that become a problem too?
So that's a real issue. So thinking about, just the general public and wanting to have their water tested, right? So you go to a laboratory, maybe they come to your house, they take your sample, and then they give you this funny looking sheet or several sheets of numbers, right? And these names of chemicals, and you necessarily don't understand what that is.
Mm,
And when you start looking at it more, you find out that, well, their detection limit was this, and they didn't find that chemical. But actually, the level that could harm you is lower than their detection limit, which means
mm.
that it might be there.
Yeah,
Oh no, because you paid a laboratory to do something that they couldn't do.
right.
So you're out 100, 200, $500, and you didn't answer your question,
Yep.
right? And so that's frustrating as a homeowner, as a tenant. Is how do I know this? And that's one of the issues with the public health system. So generally, you can go to public health departments, and they have environmental health specialists that can help you. But sometimes they're just overwhelmed. Like during COVID pandemic, they're being tasked with setting up vaccination sites, and so they're not necessarily doing the water stuff. And even if you leave a message, they might not be able to call you back because there's nobody at the phone anymore.
Mm. Yeah, and I could imagine wildfires would fall in that same category. Like they just must get so overwhelmed with everything that's going on that it's tough to respond.
Yeah, wildfires or chemical spills, or I mean, even down in Texas where they had the freeze, the thousands of pipe
Yep.
breaks.
Right.
Uh, so the environmental health group was being tasked with other issues. They couldn't necessarily respond to help with the questions about water safety in the buildings that rapidly. So
Mm.
as people had, water pressurized back into their buildings, the next question is, did you just pump in E. coli and all these other bacteria into your plumbing?
Mm.
How do you get it out? And so there's that public health issue, right? So
Yeah. Well,
disasters are hard, but also, kind of on the topic, another topic is the cured in place pipe. Those are chemical releases, complex chemical releases. And so, walking into a situation where you don't necessarily know what you're dealing with is difficult.
mm. Yeah. So I do want to talk about Cast in place. Is it cast in place plastic pipe or cured in place?
Cured in place pipe.
Right.
Yeah.
Okay. Yep. So, but before we go to cured in place pipe, is CIPP? I see that at CIPP. Do they just call it CIPP? Is that kind of the?
So I've never heard it called SIP in the industry, but many people that I talk to that are not in the industry call it SIP. So
So CIPP, CIPP, cured in place pipe, whatever it is. I do want to get to it. Um, but just generally, and this goes to like a bigger kind of issue. It's a plastic, that's a plastic product, but what are some of the general um, issues you've seen with the use of plastics and the water supply loosely? I mean, we can talk more specifics down the line, like we kind of plan on, but just loosely, where do plastic and water kind of become problematic?
So in the 70s and 80s, you might have heard of a pipe type called polybutylene, this gray plastic pipe, and it was adopted nationwide for use. It was way less expensive than copper. It was flexible. And one of the issues was it wasn't necessarily tested appropriately before it went into market, but the market doesn't necessarily test all the products appropriately before it gets to market. This was just one example.
Mhm.
Add hundreds of millions of dollars of catastrophic failures, leaks in people's homes, leaks in utility, infrastructure because the pipe failed. Historically, the industry really hasn't done a good job at making sure that the products that they're putting into inventories, building, plumbing, and such are vetted thoroughly, fully understanding how they fall apart, what caused them to fall apart, and then what leaches out. And so that's an issue that has continued to kind of simmer in the background.
Mm.
Many of the plastic pipes and other types of materials are being used in applications that they were never tested for. And, it's not surprising that you would find massive variability in how they impact water in the field because they're not tested for that massive variability before they, get out into the field.
In that leaching has some potential health effects.
So again, many of the chemicals that leach out do not have EPA drinking water standards. It's meant because the EPA drinking water standards are not based on all the chemicals in the world. They're based on a prioritization of what chemicals people know about at the time that the drinking water standards are created. So many of these chemicals leaching out of plastics or being degraded from plastics, find their way into drinking water, are not on people's radar. And for that, we are where we are today, where we don't really understand the impact of these plastic materials on drinking water safety. And there are a bunch of haphazard ways to hope that we understand it through testing.
Yeah, and we kind of saw that in the common world with the whole push with BPA-free bottles, right?
Well,
And it seems like we're now finding out that there's other variants of like there's BPS and BP other things that replace BPA and might be of equal issues. So I don't think we have to go completely down that rabbit hole, but it's not this isn't just, hey, we think this is bad. There's some research there that there are chemicals that are bad for our health, right? Potentially.
Yeah, there are chemicals that could pose a health risk. They have to be at high enough concentration. We have to be exposed to them long enough.
Yeah.
But like bisphenol A, we've heard about that for baby bottles and water bottles that people use and carry around. So they line drinking water pipes with epoxy, which is created using bisphenol A. So you may not know about it, but like, for example, in the city of Cambridge, they're using epoxy to line their old drinking water pipes now. And they're calling it cured in place pipe. It's just a different type of resin, epoxy resin. So plastics, whether you like it or not, are being adopted all around us. So if you make a decision at your home not to bring in certain plastics, but you have gaskets, so you have gaskets in your plumbing that are happening. You have pipes Maybe you avoid plastics that way, but you have, all these containers and Tupperware in your refrigerator. You got, and then maybe you go to the store and you go to some part of town that's lining all their pipes with plastic or such. So plastic's all around us.
Yes.
The question is, at what point are we going to make a decision that, hey, it would be a good idea to understand these materials better so that we can head off any potential long-term health impacts that should be preventable?
Yeah. And I don't want to go too deep into this because I've kind of talked about it a little bit in the past, and hopefully we'll talk more about it in the future. But yeah, I think it kind of falls into, I was saying in a different podcast the other day, was what is it, the phrase is, the poison is in the dose, right? But if you've got your pipes lined with it, and like you said, the gaskets are there, and your drinking bottles, and you're warming up in your Tupperware in the microwave, and then we find out similar chemicals are in your sunscreen and your toothpaste, and like um, it's that compound effect where, okay, yeah, maybe the small amount leaching from that pipe is not a problem, air quotes for people only listening. Um, it's it's really a cumulative effect that you have to look at, and that's kind of what you're saying, right? We have to figure out what is this mass of chemicals coming at us, and what's really the long-term effects. Is that fair?
Yeah, in the big picture, I think that's important. From a drinking water perspective, I think not only do we have to understand what dose is, what the exposure is for a variety of the same products, right? Because we can find products today that are massively different in how they impact water safety and water quality, but they're not tested for that, right? So the testing procedures that are in place are not meant for you or the consumer to make a decision. They're meant to get the products into your hands so that you buy them and put them in your infrastructure or your homes or well pipes and that kind of stuff.
Got it.
So at some point, we need to flip this and say, okay, the public health and safety is going to drive the decision-making process. And in order to get into that space, there's a ticket to entry, and you have to have this type of information. That's not how the American plumbing and water infrastructure ecosystem works today.
Mm.
They create a product, they create standards that may or may not have any value, they push it into infrastructure, and then they find out what the problems are when people call or when there's lawsuits and infrastructure problems.
And I was going to bring this up a little later, but I'm seeing what you just said now was pretty impactful. And we're having this conversation on the heels of a potential infrastructure bill that is going to release a lot of dollars for infrastructure. Is there a concern there that now there's money to be spent that people will say, okay, we've got old wastewater pipes, let's just upgrade them all? And is there a concern that there's going to be a big push and this is going to become a lot more commonplace? Or
I mean, I'm sure it will be. I'm sure that plastics technologies will be massively adopted because you can repair 26,000 linear feet with CIPP, and it costs you $500,000. So if you're given 10 million, you might be able to line your whole city wastewater system. So we're talking about massively transforming the interface between humans, the environment, and our surroundings from, say, metal and steel and concrete to plastic. And we can do that smartly, but the existing infrastructure and the ecosystem as it's set up is not designed to protect us in a way that we want to be protected. Do you want to know what chemicals you're being exposed to? If you don't, the system that we have today is right for you. Do you care that one pipe causes your water to smell like gasoline for a year and the other one doesn't in the same brand? If you don't mind gasoline, taking a shower in gasoline smelling water, then the existing system is right for you. So the system right now is not set up for the users, the end users being the consumers. It's set up to get products and technologies into the marketplace to be used. And if that happens, we're going to see a lot of problems surface over the next 10 to 15 years as we realize the failures of certain technologies that could have been prevented.
Yeah, it's like we have no idea what the downstream effects of everything we're doing. And it's funny, I think a lot of people, and I know myself, maybe in the past would have thought like, okay, well, it couldn't get in everywhere if nobody's tested the thing, right? Like you make this assumption that, oh, there's all these agencies and there's the EPA and the DEP and the CDC and OSHA and NIOSH and all these people, like there's all this regulatory stuff before you get to market. You think there's um, all these hurdles, but when you really start to dig, no one's checking it. And it's quite frightening. And again, even if you don't think about all that, you say like, well, what about what you were just talking about with um, polybutylene? Am I saying that right? Um, and asbestos and the insulation um, from urea formaldehyde. And think about all the products over the years that got put in all of our homes that we spend decades in billions trying to remove because we realize that they're making us sick. So if we
Mhm.
think that that can't happen all over again, and how many years from now we're all ripping plumbing pipes out of our walls? I mean,
Well, I mean, it's happening now. You just don't hear about it because no, it's in everybody's best interest. The city, the building owner, the contractor, and the technology vendor, the manufacturer, that nobody hears about it. But there are situations where they're ripping pipes out of people's homes that have failed, pipes out of the ground, liners that delaminated 6 months after installing it and caused sewage backups in multiple homes in the city. Generally nobody wants to talk about that, but that's really what can help define your process towards making a decision.
hmm,
But anyway, so one last thing is, the EPA, which has oversight authority for safe drinking water in the United States for public water systems, doesn't understand plastics. They don't have people there who have learned about plastics, who have been trained about plastics. And in the 1990s, they created a law that prompted a lot of communities across the US to change the chemical they put in the water from this chemical called free chlorine, which is bleach, to this other chemical called chloramines, which is not bleach, but it's ammonia-based chlorine. And that prompted toilets to start leaking, gaskets to start leaking. And that's because this chemical is extremely aggressive towards gaskets. And so EPA didn't consider that because primarily what they focus on is public health and chemistry of the water, not materials that water will come into contact with.
hmm,
So not only is the industrial ecosystem not set up to develop products that don't necessarily fail in use or underperform because they're not really incorporating that full life cycle thinking and bringing in people that understand water chemistry early on. The regulators don't get it either. And so we're going to continue to see this kind of stewing around and around of we bring technologies in, they fail, people are inconvenienced or they lose money because
hmm.
the insurance company won't pay for it. We're just going to keep seeing that unless there's a big change.
Awesome. All right. Well, let's get into cured in place piping, which is why we're here today to talk about it. And I think it's funny. I both my response every time I even tell somebody about it is, isn't that amazing? And isn't that horrifying at the same time? Right? Like the technology is, oh, that is fantastic. But then the dangers there are on an equal level of being horrifying. So could you maybe paint people a picture of what is cured in place piping? How does that
Yeah.
operation work?
So cured in place piping is basically chemically manufacturing a plastic pipe, a new plastic pipe inside an existing damaged pipe. So you might have a buried cast iron main below the ground or ductile iron main or concrete, and you don't want to dig that pipe up. So what you do is you manufacture a new plastic pipe inside that buried pipe. The way you do that is you take generally using two approaches. One, you use heat, or the other one, you use UV light. you take think of like a tube sock, and you take one end of the tube sock and you snake it into the buried pipe, and it ends down here. And then you can, heat it, and that tube sock will harden up. And that tube sock hardens up because it has resin saturated in it.
Hmm.
And so you basically cut the ends off the two hard sections of that tube sock, and now you have your wastewater, your stormwater, your drinking water basically just move through that new plastic pipe.
Hmm.
So it's about 60 to 80% less expensive than other methods. You can fix a pipe that might take you weeks, where you'd have cones up and traffic redirection. It might take you an hour to 3 hours, and
Yeah.
so it's massively convenient.
Yeah, absolutely. And I remember like just hearing about it. When I looked at it, it reminded me like a tube sock's a good analogy. And then even I think of like a firefighter's hose that comes flat. It's kind of like a fabric. And
Mhm.
then you just snake it through and then it expands in the pipe. And I think they said they go ahead and use some type of like they will block it off so no water or effluents or whatever is running through. They clean it with some type of like a wire brush maybe or some type of a scrubber. And then when they expand that sock or flexible hose, right, that has the resin in it, I've seen it be, I've seen a couple of them. I've heard them say like either hot water or steam.
Yeah.
And that steam is what generates the heat and gets it to essentially cure to the pipe above.
Right. So they'll have a boiler inside a truck, and they'll just pump steam at like 30 psi, 20 to 30 psi into the sock. And that the water vapor in the air contains the heat, and then it lets the heat basically contact that resin. And
Mm-hmm.
inside the resin are these chemicals called initiators, and the chemicals generate free radicals that basically help transform that mushy resin into a hard plastic.
Mm. Okay. Now you've been coming across on the install side um, some issues. I guess issues is probably an understatement, but um, some hazards. What are kind of the risks and what are the problems you started to see creeping up on these install?
So the technology entered the United States in 1975, and since then it's been increasing in use. 40% of the global market is going to be in the U.S. in the next like 5 years. So there's just a number of new companies forming that are using this practice, and with that, you're seeing more and more people get involved at the work site where they're handling these resins. They may do construction, brick and mortar construction. They may do plumbing. Um, and then on one day a week, they'll be tasked to the CIPP team where they have to handle these raw chemicals, heat them up. And so the safety issues associated with the manufacturing process of CIPP is much, much different than typical safety issues that maybe contractors would encounter other places. So we've seen a lot of chemical exposures, waste disposal issues um, that you wouldn't see in other applications, but you're seeing more and more of in the CIPP world.
Hmm. I mean, I've seen pictures where like there's kind of plumes of presumably or steam.
No, they're not steam. So
Okay.
um, years ago, the workers and company owners and people that were licensing the company's CIPP technology were told it's steam coming out of the plumes. So they take steam, like real steam, and they pump it in one side of the tube sock.
Mhm.
And because like if you were to hold the tube sock up and put water in it, water would wick out, right? And water
Yep.
would wick out because your tube sock's not
Porous.
right, it's porous.
Yep.
If we pump steam in, steam comes out too.
Hmm.
And so what happens is that the steam material looks like it's white, but it actually is saturated with volatile organic compounds in semi-volatile organic compounds. We call these VOCs and SVOCs.
Hmm.
Styrene, sometimes benzene, methylene chloride is coming out into that waste in addition to a partially cured resin. So like we're trying to cook the plastic and we're blowing stuff by it. So we're scouring out some of the plastic before it's done cooking.
Mm.
We're blowing that into the air. And then there's just so much organic material, organic vapor in the air that so that's in that white plume too. So that white plume, workers were told for 20 to 30 years that it's steam. It's not in any way, shape, or form. It's a multi-phasic chemical mixture of a lot of things that nobody should be ever exposed to.
Mm.
And that's what we've been really trying to hammer home to workers
Yeah.
because they were not aware.
Yeah. I mean, I've seen a lot of them is because of your work, but even stuff that wasn't your work, where I'm seeing pictures of workers, no respirators, just in gigantic plumes. Um, and
Yeah.
I can only imagine as a non-scientist, like I just know when something's in a, a vapor form or even gets airborne and you're inhaling it, the intensity with which it has effects on your body is increased. I would think.
Yeah, and so there's that the exposure to the waste. I mean, that's plastic manufacturing waste. And the plastics that are being manufactured as CIPPs are the same type of plastics that they made for aircraft hulls or boat hulls, except when you do that, you're in a actual fume hood. Like there's vacuums there to suck
Mm.
up the waste. You're not standing inside, the cooking chamber.
Yeah.
um, where we are here with CIPP, there's waste produced, and workers necessarily haven't been told that they should not be standing in that plume. I mean, some workers I talked to said, well, when it's really cold out, that's the warmest spot.
Yeah.
So, um, so
Disturb.
they really need to be careful and
Yeah.
not anywhere near that.
Yeah. And I would have to even imagine, I'm only completely speculating here, but um, not only a respirator, but I'm sure like there's a potential for absorption through skin as well.
Yeah, there's just so much. So gasoline is not in CIPP. So but you can go to the store and buy acetone, right? We can go to like Menards, Home Depot, Lowe's. We can buy, or True Value, or Aubuchon Hardware. We can buy um, acetone, right? And if you were to take that cap of acetone off and just shake it so all the drops come out, that is the exposure, in that there's droplets of pure organic solvent coming out of that exhaust emission. And so that's why it's really concerning that workers have been being exposed to this, and that they need to not only protect themselves from a respiratory perspective, but dermal protection as well.
Yeah, so probably even Tyvek suit. But the minute you start putting somebody in a Tyvek suit and respirator, people in the neighborhood are going to go, why are they in spacesuits, right? And probably raises a flag.
Yeah.
So I can imagine that's.
And it can be done safely, right? So you can protect workers and do CIPP safely. And even if they're wearing Tyvek suits and respirators for the certain activities, that can be done safely too. One of the issues though is that the waste is leaves the work site, sometimes goes under sewer lateral, goes through sewer laterals into nearby buildings.
Hmm.
And years ago, down in Cambridge, they had an issue near Harvard where waste went into a building and I think caused people to get sick. It was a big, big issue. The Harvard Crimson did a little story on it.
Uh,
So it happens, and that's an issue too, is preventing your waste from moving off site and affecting children and other people nearby.
yeah, and there even seems to be this a fair amount of news reports out there of a number of people, just public ending up, going to the hospital because they're sick or because of the fumes or um, exposure in that way. So it appears to be there's a public safety issue with the byproducts that are coming out or waste, whatever the right term is there. there's the worker safety piece of it. And I believe even recently there was a lawsuit settled about a gentleman that there was a fatality. He died using the product. It seemed like he maybe went down into the hole to make a repair or something like that, and got overcome from the plume, and I believe drowned in the liquid. Did I
Yeah.
read it correctly?
Yeah, he was 22-year-old.
Brent Morrow, right?
He was working as basically a summer job on a construction site. He went down to the CIPP that was in a sewer. He was skinny. He was sent into the hole because he was small.
Mm-hmm.
And then the liner collapsed behind him and he couldn't get out. So he wasn't sent with respirators. Reportedly, the safety company that was advising the CIPP company didn't train them on how to handle the resin safely because they assumed, 4 gas meters were appropriate, which are not.
Mm-hmm.
And, they didn't really realize respirator protection was needed. So it was tragic. But the lawsuit involved not only the safety company that was supposed to have trained the CIPP company workers, the city where the fatality happened was also in the lawsuit, as well as a consulting engineer who helped decide that this pipe should be repaired using CIPP. So a number of different parties that you typically hear about that say, well, it's the contractor's responsibility if anything happens there. Well, everybody was dragged into it because everybody had some, in the court's eyes, responsibility.
Yeah, that's a great segue, because the next question I had was, where really is the breakdown? Because there's so many people, and you didn't even say you can go one step further back and say, how about the manufacturer? Like where is the breakdown from the manufacturer to the designer to the municipality that is saying this is the way we want to do it, to safety consultants, to the installer, or even are there regulatory groups or enforcement groups that are, I don't want to say part of the problem, but also could be part of the solution? Like, what do you think? Where's the breakdown, and how should should manufacturers be providing better information, saying that you can't I mean, just suggestions? I know there's probably no one solution, but I kind of think a manufacturer should say, these are the installation instructions. Here's the training that you need to go to before you can install, transport anything, this product. And a regulatory check in there maybe too, to make sure that, like right now, if you're doing hot work in Massachusetts, you need to be certified. So, and fire department or building department can, when you come out to site, and say, can I see your certification? Well, because rightfully so, you can harm yourself and a lot of other people. So it seems like there should be some system. I don't know if it needs to be that intense, but is that a possible solution? In your eyes, what would be like a reasonable approach to kind of at least get started?
So
Sorry for that entirely too long question, but
that's a good question. Initially, I thought that if we showed workers and CIPP companies the problem and we gave them solutions and we gave them, and NIOSH conducts free worksite testing, confidential. Like, they don't tell anybody where they went or we came to your company. They share the results publicly, but it never gets linked back to you. So we figured, well, if the government will come in and do free testing and never tell anybody where they went, then you can, as a company owner, you can have your own worksite tested. It turns out companies won't do that.
They don't trust it still.
I don't know if they don't trust it. There was a bunch of companies that got together that did testing behind closed doors. There's another bunch of companies that did testing separately behind closed doors that I've talked to. Nobody knows what they're going to find, and so they don't want anybody doing any testing with the potential for it to go public.
Mm-hmm.
And I understand that, but the issue is time is of the essence. Unless you stop using CIPP and tell all your workers to go sit on the bench until you figure out how to use it safely, I have a hard time understanding why things are not happening as rapidly as they should be.
Mm.
So, what are the roles? OSHA needs to get involved because there's a whole group of workers, including supervisors and environmental health and safety professionals, who contact me asking for advice. And I give it to them, but I guarantee you there's got to be more people that aren't calling. And they either don't know or they're getting bad advice, like that company out in Illinois where the 22-year-old was killed. A safety company advised the CIPP company incorrectly based on the lawsuit, and a 22-year-old died. So if you're owning a CIPP business, or that's one of your businesses, services that you offer, are you getting the right advice? And if, well, what if you're not? Well, if you're not, somebody can die, like one of your friends and colleagues on the work site. And so that is completely preventable. So I think, workers and companies need to start reaching out for help outside their typical communication channels, because there's just too much at stake. Everybody who goes to work should be able to come home that night.
Yeah, that's our industry. That's what we say every day. Everybody has a family to go home. Let's make sure everyone goes home safe. And that's become part of the culture. But I think as new products and new technologies come in, people are not aware of their exposure. And I kind of feel for that company. If they hired an outside safety company to come in, they were trying to do the right thing. They hired somebody and said, please come in and train our workers how to do this safely. I'm assuming they followed those safety instructions. It sounded like if they had the gas meters there or whatever the meters were, like it's hard to find fault to that company, at least from my standpoint.
They try to do the right thing, and so if you try to do the right thing and the entire system fails you, and somebody dies on your work site, was it preventable? Probably, but there were multiple levels of failure. And how do you, as a company owner, let's say you're doing general construction and CIPP is one of your, subcontractor sub businesses. I want to make sure that there's nothing that goes on in that group that exposes my people to harm. And I would do anything and everything to go find a way to make it happen, because construction is about people, right? We build infrastructure for people. We help people. It's a people business. And I think that with these new technologies, as you mentioned, people need to have an extra antenna to pay attention to the challenges that they may face, and then the ways to solve them. So there are solutions, right? CIPP is not a bad technology. It's a great technology. The problem is it's being used irresponsibly sometimes. And sometimes the people using it irresponsibly didn't even know better because they weren't taught how to use it responsibly. But I think that's one of the issues. Now, you had asked before, what about other groups like the cities? Are they responsible, or consulting engineers? Well, I'll tell you one thing. The cities are driven primarily by money. And when it comes down to it, they're going to put out a bid spec and they're going to try to push all liability onto the contractor. But this lawsuit in settlement in Illinois shows that even when they try to do that, they are still exposed. And they were, as far as like the consulting engineers, sometimes they do what the cities want because they don't want to lose business. The city will tell them, well, if you won't recommend this process, we will fire you and we will hire somebody else to be our town engineer. Like, that's just how it is. And so, so I don't necessarily see them as being the torchbearers for protecting workers and preventing preventable deaths in their community. It would be great if they did, but I think it's going to take a lot of internal motivation by CIPP company owners or general contractors that do CIPP to protect their friends, colleagues, and family from harm on the worksite.
Yeah. I mean, I think it's not because you're virtually sitting here with me, but I think the work you're doing is just tremendously important because the people that don't know, they're in the municipal sector or they're an engineer or whatever. If they don't know, they don't know. That's not on them, right? But the reason I'm really excited about this podcast and I want to push it out as heavily as I can is people need to know, right? People need to be, and I don't mean this in a mean way, but they need to be put on notice that like enough's enough. Knock it off. People are getting harmed. People are getting sick. We're not doing this right. There's no checks on this. Well, there's a lot of times where there's not the checks happening. Like you have something that you're doing that has the potential to be very hazardous. We have to address it, and I think it's important. We need to get that out. And then if that person does that, then shame on them and I'm fine suing them, putting them in jail, whatever. Right. But we're at this point right now that people just don't know, don't truly know. So like we've got to get that word out. It's
there's
critical.
We're there partly because of industry groups pushing false information on purpose and trying to corrupt the discussion about safety. So it's not that CIPP isn't safe ever. It's that it's being used under certain conditions that expose people to risks, health risks that they don't even know about. They don't get to have a say in whether or not they stand in the plume, right? Because the steam gauge is typically put at the end of the rubber tube, end of a CIPP, and it's put right in the steam plume sometimes, or the waste plume. So we need to give workers the ability to have a decision on whether or not they want to do this job with the risk associated with it. We also need to protect them, prevent them from things that just shouldn't happen. And awareness is important. And we also need workers and company owners to recognize that it's in their best interest to do it right, because we cannot have another asbestos or some other type of worker safety disaster. And with this infrastructure bill, which is great, we cannot basically expose a whole new generation of workers to hazards that we didn't protect them for, and that we'll be talking about 50 to 100 years from now.
Yep.
So I think that's really important for us and for the community as a whole.
Absolutely. I remember, so my dad was an insulator, and growing up, I remember the magazine, it would show up and it would say, Insulators and Asbestos Workers of America, right? That was just his title, right? It sounds crazy right now, right? But that was it. That was their logo. That sounds insane, right? In hindsight. But, do we look back in hindsight after this and say, like, what were we doing? I know you're not saying that, those are my words, but, as a non-scientist and non-engineer, I just look at this and say, like, again, my words, not yours. Like, I'm just concerned even with the byproducts, with just even like the microplastics, when all this stuff is the waste products are coming out. Some of that has to be ending up back in the soil and getting into the waterways, and then what's leaching from there's like so much unknown here. To me, I'm just shocked that the manufacturers aren't more worried about the downstream effects that they're going to have to deal with. I mean, I have to imagine
I don't know what their relationships are with their licensees, right? I mean, what type of what they sign over, what type of training that they give. I mean, I know I've talked to several CIPP company owners, and they were shocked, and they've been angry too, that they get themselves into a technology that they didn't quite understand what the implications were, and they've been using it for years with their workers, and their workers weren't necessarily protected the way that they should be. Because for years they were told it's just steam, odor's not a health risk, and it's only styrene at very low levels, when none of that's actually true.
Mm.
So anyway, so there's a lot of angst with company owners and workers, and even EHS safety reps from these companies. You know, they'll be using 4 gas meters on site, which is completely inappropriate for this technology, because 4 gas meters will tell you everything's fine because it won't detect anything that's being emitted.
Mm.
So yeah, we need to help these people. So if you see them, you know, doing work on the side of the road, you know, just you be kind to them, recognize that they may not know what they're being exposed to, you know, and we need to help them any way we can.
So what are some good steps for people to take if they're like, I guess if you could have your dream scenario, what would that be? And then the kind of follow-up is going to be, but all right, we're not in a dream world. So what are maybe some practical things people could do? Like ideally, would you say we should hit the brakes on this product until we figure out? Um,
So I know based on the
Dream
last,
world.
yeah, I mean, based on the last 4 years, people are going to keep doing what they do as they do it with relatively no change. So regardless of what's said, the money train has left the station, right? Cities are still going to spec it. They're going to use it. Workers are going to show up on site. They might be harmed. It's going to happen. I mean, it's inevitable that this happens unless something drastic changes. And the first thing drastic, I think, is workers need to know what's going on, and they need to get their information not from the organizations that are designed to keep them focused on what they want them to know and what they don't want them to know. So they need to branch out. OSHA will talk to them. They don't have to file a complaint. OSHA will talk to them about things. NIOSH will talk to them. We will talk to them about things, answer their questions, whatever they may be. So there needs to be an awareness. Secondly, to make the product safer, you would reduce the amount of waste you generate. So you can change that by resins. So resin manufacturers can change the resins to make them, you know, release less waste in the air. That's doable. We're working on some of that here separately. You can also capture the waste. So if you have a steam blown in on one side, then you can just have a system on the other side suck it,
Vacuum kind of, yeah.
right? So you're not talking about a big footprint. And so there's things that you can do that make it relatively easy. But in the last 4 years, industry's not interested in doing anything different in my eyes because they're making, you know, hand over fist money as they are. So unless something changes externally, I don't see it changing significantly for worker safety.
Okay. So awareness is huge. Try and get it on OSHA's radar. OSHA's just they're running so thin. They don't have the staff to really do true enforcement. I would say the awareness there's a whole division of safety professionals out there. Love to see them be more aware of this, this being an issue. And then I guess, is there anything else? I mean, as far as like, I feel like there must be more from a manufacturer standpoint, or what could contractors do? You think reaching out to NIOSH to try and get testing would
NIOSH will
help?
do free testing, like 100% free. There's no cost, and it's confidential. So companies, their name will never hit the news. They nobody will even know that NIOSH showed up.
Hmm.
So like it's completely free. One company did it, and they were able to find that one of the practices that they use when they create CIPP, UV CIPP, ultraviolet light CIPP, generated a worker safety issue. And so they're able to nip it in the bud. And that was it. So they're out there probably making hand over fist money because they're the only ones with basically they could say a NIOSH badge, right?
Hmm.
A safety badge. Like we got vetted and we're good and we're moving on. It's just free, confidential advice.
Yeah.
You can also go, as you said, the industrial hygiene community, the worker safety community. But you got to be careful because not all industrial hygienists or worker safety professionals recognize the complexity of the plastic manufacturing process, right? So
Right.
this isn't just a typical, dig and trench job. This is a little more complex than that.
Yeah.
So you need to be advised appropriately.
Okay. All right, Andrew. Well, it's already been over an hour. Um, I appreciate your time. I know I said it before, but this is so important. I appreciate the fact that you're out there doing it. Um, Anything I can do on my end to help spread the word, I will. I've already thought about, there's different safety groups that I know of locally here in Massachusetts, and I'm going to get this information to them. That's their livelihood. They talk about it. We have a great program here locally at Keene State in New Hampshire where they have a safety program. I say we try and get it on their radar as well, so it just becomes more and more known. Um, Whatever I can do on my end, I'm going to do it. If there are people listening to this that um, can help spread the word and we can be part of it, and maybe reach out to Andrew's group with what they're doing. If you don't mind, I'll give your Twitter account a plug. What's the handle on it?
It's at the Whelton Group.
At the Whelton Group. Andrew shares some great information via Twitter. He's on LinkedIn as well, Andrew Whelton. But he shares a lot of interesting stuff where I see it come through and I go, oh wow, I got to read that article. I got to read that article. You give me too much to read, but it's all great stuff. And so please give Andrew a follow, share that information. Every little bit helps. You like or you retweet something or you share this podcast. We got a long way to go because I venture to say 99% of the people that will listen to this, probably don't even know that cured in place piping exists, and if they do, they definitely don't know the hazards with it. So I appreciate all the work you've done. I appreciate you coming by today, and I look forward to us talking again.